So today we're going to be doing 10.6, which is going to be graphing trigonometric functions part 1. So this is going to be a two-parter because it requires a lot of different things that we're going to be talking about. So it takes 2 lessons for this. So let's just go through some of the vocabulary. So a periodic function is a function that has a repeating pattern of y values at regular intervals called cycles. While all trigonometric functions are periodic, we'll focus our studies on sine and cosine only. So in this class, we're only going to be talking about sine and cosine, the two, basically the main ones. But when you take trigonometry, like you take a trigonometry class, you're going to be doing all of them. Okay. So this is just like a preview. Yes. Sure. You do. I'm sorry. Okay. All good. Thank you. So, here's some of the vocabulary. So, midline is a horizontal line located halfway between a periodic function's extrema. So, the midline is this right here. So, this is the midline. The amplitude is the distance from the midline to any max or min. So that would be these distances here from the midline to the max or min. The distance is the same, and these are the amplitude. Okay. And a period is the horizontal length of one complete cycle. Periods can start at any point on the graph. So a period means that we have completed an entire cycle. Okay, that's how we define a period. So is everybody good with this slide so far? Okay. So graphing the parent sine and cosine function.
I'm sorry, what was the last of the, like the height?
Amplitude.
That was the lowest height, right?
There's 2 that fill in amplitude.
Oh, 2 of them fill in amplitude?
Yep, this one and this one. Alright, so graphing the parent sine and cosine functions. We are now going to take what we know about the unit circle and graph some of the values on the coordinate plane like any other function. Because we are now using radian measures to represent angles, we are able to treat the periodic function sine and cosine like any other function with domain and real numbers. So, I'm going to zoom in so we can look at the unit circle and we can talk about the graphs and how they work. So this is the unit circle. You've been dealing with this for a few, weeks now, right? Or about a week. So everything you do when graphing trigonometric functions will always be in radians, okay, instead of degrees. So basically, you remember that cosine is the x-coordinate, sine is the y-coordinate. So basically, we look at the unit circle, we determine the radian that we're on, and then we determine the corresponding sine or cosine with that when we do our graphing. So, the x-axis are the radians, okay? The y-axis is the output, okay, what we get, what the ordered pairs. So if we look at sine of 0 degrees or sine of 0 radians, what's the value?
1, 0, or 0.
Just 0, because it's only the y-coordinate. So you're going to plot it at 0, 0.
So sine, what was that again? You did sine
Of 0.
Sine of 0.
Yep. So now we're going to look at the next one. Sine of pi over 2, which is the same thing as 90 degrees, which is 1. So at 90 degrees, we're at 1. The next one is going to be sine of pi, or 180, which is going to be 0, because it's the y-coordinate, right? And the next one is 3 pi over 2, which is 270. And that is sine of -1. And then the next one, 2 pi is right here, back here, and it's still 0. Good. So this is how you would do the graph. These are the basic values of the graph. You will start to memorize these as well. And then let's talk about the negative values. So I want to just help you understand first why, and then we'll talk about a simpler way to think about it. So if we think of a coordinate plane, when we do a negative degree measure, we don't go counterclockwise anymore, we go clockwise when it's a negative degree measure. So this is basically negative 90 degrees, if I convert it to degrees, right? So that means I start on my initial side and I go negative 90 degrees. Now, what positive angle would that be coterminal with? 270. So this actually has the same value as 270 does, which is 3 pi over 2. So, for that...
I'm sorry, negative pi over 2 is equivalent to negative 90 degrees?
Correct. That's it's radians to degrees. So that's negative pi over 2. And see how it actually follows the pattern of the graph? See the pattern that's starting to form with the dots? See how it's following? And then from here you can just start following the pattern. You don't have to do all of these by hand. I just wanted to show you why it works. Because they are coterminal with each other, okay? And once you have that snake shape, you're just going to connect it. And this is what a graph of a sine function looks like. It oscillates. So is everybody good with how we got this so far, using the unit circle? Now we're going to do the same procedure for cosine, okay? So cosine is not the x-coordinates, but it's the, not the y-coordinates, but it's the x-coordinates. We're going to do the same procedure, but now we're reading the x-coordinates. So at 0 degrees, cosine is at what?
1.
Good. At pi over 2, cosine is at 0. At pi, cosine is at? Good. At 3 pi over 2, cosine is at? 0. And at 2 pi, cosine is at? 1. So it has this like ice cream bowl shape on the side here. You can kind of tell the difference.
Like an absolute function kind of?
No.
Or like the absolute graph or whatever it is that we did, the V graph.
Oh, no. It's gonna look a lot different. It's gonna look more like this.
Oh.
You'll see. Because it has like this wave pattern. I see what you're saying though. If you were to just connect it straight.
Yeah.
Okay, I see. Yeah, no, it's a little different. I see what you mean though. So this is gonna follow the same pattern, okay?
Is it always going to be symmetrical?
Yes. Maybe it could be symmetrical over, not always over the y-axis, but it will always have symmetry somewhere.
Okay. That helps.
So then you just connect it as a curve, okay? So that's where it comes into play. I see what you're saying now, why you thought that, but no, it connects as a curve. So that's the cosine parent function. So does everybody see the similarities and difference between sine and cosine? Aren't they pretty much the same graph? But one of them is just a shifted version of the other. Does everybody see that? Alright, so that's an important key factor about these. And that's just because they all take on the same values, just at different times. So that's the reasoning for it. So now that we've talked about that, we're going to go on and talk about what amplitude and period are. Okay?
Can you go back to that B real quick?
Sure, not a problem. Sorry, when I'm zooming in, it's hard to I don't want to take up, if I zoom out, it's probably too tiny for you to read it.
Yeah, thank you.
You're welcome. So now we're going to look at amplitude. So amplitude is the distance from the midline to the max or min. So just for understanding purposes, I'm going to put the midline in the sine graph just so you can see it. So everybody see why this is what we would call the midline? And the equation for this line would be y equals 0. Okay, and see how it cuts the graph into 2 equal pieces. Now, yeah.
Is the midline always going to be the...
No. Not, you're going to have shifts of the graph where it shifts up and down, and that will affect it. But good question, no. So this right here is amplitude, okay? So what's the amplitude in this case? 1 unit. Now, the period of any standard cosine or sine function, unless it's been changed, unless we've changed the period, is just 2 pi. And we'll talk about how the period changes, but that's the standard period, okay? The domain of this function, it goes to the left and right forever, right? With arrowheads, it'll just keep repeating this pattern. So the domain is, good, negative infinity to positive infinity. And what would the range be? Is this graph going up all the way or down all the way? No, it's staying bound between 2 values. Which 2 values?
1 is negative 1.
Very good. So the range is from negative 1 to 1. Now, just a tip, your range will always correspond with your amplitude, typically, okay? The only time that it's not going to correspond with your amplitude is if we have what we call a vertical shift. But typically, if you don't have a vertical shift, it's going to correspond with that, all right?
So how did you get amplitude and period again?
Amplitude is just, period is always 2 pi unless otherwise stated, which we'll talk about.
Okay.
Amplitude is just the distance from the midline to the highest point on the graph.
Okay.
Okay? So, is everyone good with those basics? We're going to start talking about actually graphing these. So, alright. So, I'm going to go through the procedures of graphing, and then we'll start graphing. So, we're going to talk about changes in amplitude and period. That's what we're going to be focusing on today. So, these are the standard sine and cosine functions, where A represents something to do with amplitude, and B represents something to do with the period. So, where theta is in radians, the amplitude is actually, and it's funny you say that, because we are going to be talking about absolute value a little bit. The amplitude is the absolute value of A, okay? And the period is if you take 2 pi, and you divide it by the B value. Okay, that's this value right here in front of theta. Now, in most graphs, unless you have a B value, your B value is just an implied 1, which means your period is just 2 pi. But if there's something other than a 1 there, that's when you know the period is going to change. So now that we learned our formulas, let's go ahead and put it in practice for these 2 examples. The amplitude of this is the absolute value of 3, which is?
3.
Good. And the period is 2 pi divided by what?
B.
Good. What is B this time?
1. 2.
So in this case, would A be 3?
Yeah.
Oh, this isn't 0. This is
Oh,
theta.
Oh, yeah.
I see why you thought that, but yeah, no,
Yeah.
it's theta. It's theta.
So would 3 be A?
Yes. This is A, and this is B. All right.
And so it's always for A, absolute value, and then for B, 2 pi divided by B.
Correct. All right. So here the amplitude is the absolute value of A, which is just 3 over 2. And our period is 2 pi divided by 1/3. So we have to do keep, change, flip. You remember that? Keep, change it to multiplication, flip the fraction. This comes out to be 6 pi. So is everybody somewhat good with these 2? Okay. So I do want to just, before we get into graphing together, I want to just show you what I mean by what a period and some of these, a period shift and or a period change and an amplitude change would look like. So if I graph on Desmos, this is your standard sine function curve, the one we just graphed together, right? And this is from 0 to 2 pi. Okay. They actually use the different units, but now this is what an amplitude shift looks like. See how nothing changes except for that it's higher up for each one, okay? That's an amplitude change. A period change means that it actually basically occurs faster now, squished. You can also have a period change that makes it occur slower, Alright, so that's kind of what that does to your graph. And then the other thing we'll talk about today is also a reflection. Flips it. So those are the main three that we're going to be doing today. And Desmos is really helpful here for this. So now let's go ahead and try the next one. So we're just going to talk a little bit about graphing sine and cosine, amplitude and period changes. So this is just the descriptive part. So graphing sine and cosine is a 4-step process. Today we're going to be talking about amplitude and period, but tomorrow we'll start bringing in phase shift, not tomorrow, but next time you have me, phase shift and vertical shift. So start with the function in standard form. So this is the true standard form of the sine and cosine function, where we involve the horizontal and vertical shifts. Now, in the world of trigonometry, instead of calling it a horizontal shift, we call it a phase shift, but it does the same thing. It just shifts it on a phase. That's why they call it that.
So we could label phase shift as horizontal shift.
Sure. And an increment by the period divided by 4. So increment is basically what's the next critical point that we're hitting on the graph. And then we're going to graph the pattern along the midline, which is equal to y equals k. So that's how you find your midline, y equals k. So I think the easiest way for me to show you this is just to actually jump in and do a problem. Because that's typically how I like to do it in my class. Makes it easier, I think. So let's go ahead and look at example A. So the first thing you want to do is, sometimes this is helpful, is to rewrite it in its full form. Okay? So its full form includes the A value, which we already have. It also includes the B value. Now, does this function have a B value here? No, so it's an implied 1. It's an implied 1. Because it's like, you know, with a x, the implied coefficient is 1. Think of B as the coefficient of theta. So it's an implied 1.
So, Ms. Russell.
Yeah.
So, why are we multiplying the A by sine again? Is it that?
I'm just rewriting this function.
Okay. Yeah, my fault. I was like, wait, why are we doing?
No, that's okay. So then we have our phase shift, which is -0. If we're not shifting at all, it's -0. And then we have our vertical shift, which is +0, because we're not moving it up or down. Now, to help you understand, this is A, this is B, this is H, and this is K. Okay. So I just rewrote it with all this extra stuff in it that isn't necessary, but it helps us kind of see what we have and what we're missing, what kind of shifts happening here. Okay. So we find the amplitude by doing the absolute value of what?
The A.
Good. Which comes out to be?
4.
Very good.
So, Ms. Russell, why did you do the theta -0 again? Or like, where did you get that from?
It's just, you know how if I take your age and subtract 0 from it, it doesn't change it?
Mm-hmm.
I'm just showing you what it would look like if we did have one. Like it would be here. But this time there isn't one, so it's just -0.
Oh, okay.
And then we have our period, which is pi/2 divided by b, which is 1. So it just remains pi/2.
Oh, so, okay, I see now. So hypothetically, you could say like +0 too. It's just plus.
It would
just
shift
theta
it.
plus or minus h.
Yes.
Okay, I see what you mean now.
Yeah, that would shift it left or right, but this time it didn't shift, so it's just 0.
Oh, okay, I see what you mean.
So the midline is y equals k. So that's why I wrote the k in to show you that. Now the phase shift deals with your h, and this time our h is 0. To find increment, you take whatever the period is, and you divide it by 4. Okay? Always. That will reduce to pi/2. So what increment means is every pi/2, every 90 degrees that we go, we hit another critical point. That's what the increment means. That's where the critical points hit. And, yeah?
So increment's always going to be period divided by 4.
Yes. The vertical shift is 0. That's k, which is 0. And then we're going to wait on domain and range to see our graph and look at that and see where it is. So, the easiest way to graph this, I think, is just to start plugging in values and thinking about it. So if I take my function, I'm taking the basic form of my function. I'm just going to plug in for theta the first value I have for x, which is 0. 0 radians. What is sine of 0 radians? We did this on the last slide from the unit circle. Sine of 0 radians is 0, isn't it? So 4 times 0 is actually just 0. So this one still starts at 0, 0. I'm just plugging in these values.
And this is for, so which one would we be looking at on this one? Would we be looking at the, we'd be looking at the y value?
Correct. So next we're going to plug in pi over 2 in for theta. This value here. What is sine of pi over 2 according to your unit circle?
So wait, the 0 was supposed
1.
to be a theta?
I'm plugging in for theta. I'm replacing
Oh.
theta with 0. Yep. It's not supposed to be a theta. So that's going to give me 0. Pi over 2, 4. Now we're going to plug in pi for theta. So you don't have to do this all out every time. I'm just showing you the most extensive way to do this, okay? So this is y equals 4 times 0, which is 0. And then the last one that we're going to do, and then you maybe can start seeing the pattern, is y equals 4 times sine of 3 pi over 2. Anybody know what that is? Negative 1, which is negative 4. Good. Negative 1 times 4, and that's down here. So now that you've gotten a few points, does everybody see the pattern that it's going to take? Good. So once you can identify that pattern, you can just continue with it. So that every single trigonometric function is periodic. Especially sine and cosine, you can just take the pattern and run with it, okay? So once you have a pattern, it's going to follow that pattern continuously. So you don't need to do every value, you can just find it. So then you connect it.
So where do you get the 0 and the pi over 2 and the pi and then the 3 pi over 2?
Oh, where am I getting them to plug them in?
Yeah.
You know how usually with any graph we take the x and plug it in to get the y?
Oh, so you're just taking them from the
I'm taking them from the graph.
Oh, okay.
Exactly. And then you understand how we got the values for them?
Yeah, it was just where they came from. Okay.
Gotcha.
I got you.
Any other clarification questions?
So he was basically saying where did you get the values from?
Yes, and they're from the x-axis. I'm taking them right off the x-axis and plugging them into my function.
Oh, so if it was different,
Yes, if theoretically we did something else, yes, it would be
you'd
different.
be plugging into different values?
Correct.
Not, okay.
Yep.
I thought it was just also the ones for the
Well,
table.
purposefully, yes. So the domain of this function goes on forever. So the domain is good. In the x direction, it goes on forever in both directions. Now my range is bound. Okay, up and down, it's bound between what two values? Negative 4 and 4.
So domain is your x and range is your y, right?
Correct. All the possible values for x and y. Alright, is everybody good with this procedure? We're going to try another one together. Okay. So, first thing we're going to do is we're going to write it in its complete form. See if we have anything that needs to be looked at. So that's y equals negative 2 times sine of b times theta minus 0 plus 0. So I just threw in the h and k that we didn't have. So this is a, b, h, and k. So we didn't have a vertical or horizontal shift, therefore it's just 0 for both of those. If you did, they would have to tell you it. Amplitude is the absolute value of a, which comes out to be what? 2. Good. The period is pi over 2 divided by b, which in this case just becomes good. the midline is y equals k, which is good. Phase shift, did we have anything affecting the h this time? Nope, it's 0. The increment is the period divided by 4. So what that means is every pi over 4, we have a big critical point. Pi over 4 is 45 degrees. So every 45 degrees, this graph changes instead of every 90, which means this graph is going to change much faster than the last one did, okay? That affects its period. This one has a full rotation in only pi. In only 180 degrees, this one does everything. The other one took 2 pi to do that. So you'll see the difference on the graph. Vertical shift, nothing, it's just 0. K is 0, that corresponds with K. And then we'll wait on domain and range until after we see our graph. So with this graph, I'm going to plug in a few points just to show you what's going to happen, okay? So like I said, once you get familiar with this, you don't need to do this every time. This is just me, explaining it in depth. So we have our function, y equals -2 sine of 2 times theta. So the first theta we're going to be plugging in is our 0. We're going to be plugging in 0 right here because we want to find the corresponding y, okay? What is 2 times 0?
0.
Good. So we want sine of 0, which we found out is always 0. So -2 times 0 is 0. So this still starts at 0, okay?
Do most of them start at 0?
For sine, yes. Cosine usually starts on the amplitude.
Okay.
But sine, yeah.
Yeah.
Now we're going to try pi over 2. I want to show you what happens. So it's up to you if you want to write this out, but I'm just going to show you what happens. So I plug in pi over 2. What's 2 times pi over 2? Well, that just becomes 2 pi over 2, which just becomes what? Pi. Anybody remember what sine of pi is? It's just 0. So this one also comes out to be 0. And spoiler alert, if you plug in pi, and you did the math, it's also 0. And if you plug in 3 pi over 2, it's going to be 0. And if you kept going, these are all going to be 0. Every other one comes out to be 0. And you could test this out and do the math I just showed you. And I promise it works. So something's wrong here. Anybody have a guess on what's going on? This graph is going faster, so the values in between are actually the ones that have the amplitudes, okay? So what we have to do is we have to find a value between that. So for the sake of room, I'm going to erase this so we can talk about it. So think about it in logic here. This is 0 degrees, okay? This is 90 degrees. What value would occur between those two?
45.
45 degrees. So this is 45 degrees, aka pi over 4 in radians, okay? So what we're going to plug into our function is pi over 4. So that's y equals -2 times sine of 2 times pi over 4.
Wait, so how did you know it was 45 degrees?
Halfway between 0 and 90 is exact, yep. So that's y equals -2 times sine of 2 times pi over 4 is just pi over 2. What is sine of pi over 2? It's 1. What's -2 times 1? Good. So this is actually down here at -2. So now that we have all of that, we can now see the pattern. So everybody's starting to see the pattern. This one's going to be up here at 2. You could test that out if you wanted to. This one's down here, up here, 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 and here. And then we'll graph it. So not only is this graph having a smaller period, okay, it's happening quicker, right? Squished, more squished. It also has a greater amplitude. It's stretched this way more. And anybody else notice any other difference about it? It's actually reflected over the x-axis. Does everybody see that? So I think it's a little bit easier to see this visual in parts, okay? So let me show you what I mean by that. So this right here in the green is a regular sine function, okay? The generic one. Let's say we take it and we flip it across, we reflect it. Okay, that's the first thing we did to our graph. We reflected it, we increased the amplitude to 2. And then we changed its phase, we made it go faster. So those are the 3 things we did to the graph. Now you can look at any of these things happening individually and see that piece by using Desmos. So does everybody see what I'm saying by that? We did 3 things that changed the graph. So does everybody feel okay about this one, this question? Only thing we have to do is domain and range, right? So what's our domain here? Negative infinity to? Good. And the range? Negative 2 to 2.
Could it, for the range, could it be either or, like 2 to negative 2, or does it have to be negative 2 to 2?
Has to be in chronological order.
Okay.
Yep. Okay. So let's try the next one. So we're going to rewrite it. Y equals 1 times cosine 1/2 times theta minus 0 plus 0. Now notice here we didn't have an a, so I put in the a as the automatic 1. Okay, this is a. Because we didn't have one. If you don't have one, your a is 1. This is b, this is h, and this is k. So in this case, our amplitude is going to be the absolute value of 1, which is 1. Our period is going to be 2 pi divided by 1/2, which is actually 4 pi. So do we have any predictions on what this is going to do to our graph? So this graph takes a whole 2 rotations around a circle to complete itself. Meaning it's going to go slower, okay? The period's going to go slower. The midline is y equals k. The phase shift is h, which is 0. The increment is the period divided by 4, which in this case comes out to be pi. And the vertical shift is 0. And we're going to wait to do range and domain until we look at the graph. Correct. Yep, you take the period and divide it by 4 for the increment. Everybody good with those 6 that we did? Alright, so now we're going to start plugging values into our function. Now keep in mind this is cosine. This is not sine anymore, so it's going to be a little different. Y equals cosine of 1/2 times, let's plug in 0. We're plugging in the first value here. What is 0 times 1/2? Good. What is cosine of 0? It's not 0 anymore, it's actually 1. And if you look at the unit circle, which I know you don't want to keep flipping back, but that's where I'm getting it from, just so you know. Okay. So it's actually at 1. Cosine of 0 is at 1. Now we're going to plug in this value right here. So we got cosine of 1/2 times pi over 2. This is y equals cosine of pi over 4. Anybody remember what pi over 4 is in degrees?
So wait, Ms. Russell, 1 second. So what are you plugging for? Did you plug in 1/2 for data? Or?
No. 1/2 is already what's in the function. I'm just taking things and plugging them in for theta.
Oh, okay. Oh, okay, I see.
You see it now?
Yeah.
So cosine of pi over 4, that's just 45 degrees. We know that cosine of 45 degrees is radical 2 over 2. Now, not too nice to graph, but what we can do is get a decimal approximation, right? Just to see where it is. So in my calculator, you know, my calculators keep disappearing on me. There it is. It's much better to use this than my other one. So I'm going to do radical 2 divided by 2, and that's approximately 0.7. So here, my graph's at 0.7, so about here. Okay? So next value we're going to plug in is pi. So we have y equals cosine of 1/2 times pi. What is 1/2 times pi really going to be? Pi over
2.
Good. Anybody know what cosine of pi over 2 is? It's 0. So this is at 0. So are you starting to see the pattern on this one a little bit? So this one's going to go down here and be at negative radical 2 over 2. This one's going to this one's negative radical 2 over 2.
Wait, do you put it in between the pi over 2 and pi? The third one?
Which one?
The purple dot.
Oh, yeah, I don't know why I did that, I'm sorry. That was my mistake. That makes a lot more sense. I was like, wait, that's not right. It's at 0, right here.
Oh, yeah.
Sorry about that.
I was really confused.
I apologize for the confusion. I was confusing myself for a second. I'm like, that's not right. I didn't mean to do that.
So wait, is the green dot supposed to be like half, like 1/2?
It's 0.7 when we did
Okay.
so it's like right about in the
Yeah,
middle.
I wasn't sure if like you
No.
just like put it a little bit higher.
Yeah, it's just about 0.7, so I just kind of estimated. And then this one would be down here. So if you plugged in 3 pi over 2, it'd come out to be negative radical 2 over 2. And then it's going to bounce back up right here. Bounce up a little bit more. And then all the way up. And then over here, it's going to be here. So this graph's going to look like this. So it should look more like my left side. This guy got a little wonky, but maybe you get the idea. So I'm going to put these dashed lines in to maybe see if it helps you see something. So this graph is bound right here, right? Bound between what two values? -1 and +1, right? So my domain remains the same, -infinity to +infinity, but my range is from -1 to 1. Still bound between -1 and 1. So I'll show you this on Desmos to get like a better view of it. So if we have our original cosine function, cosine of x,
What
okay?
was the range of this one?
-1 to 1.
Okay, thank you.
You're welcome. This is y equals cosine of 1/2 x, right? So do you see the change that's happened between the two? It's basically stretched out now. Like I took it and I stretched it this way. Okay, that's the difference. So this graph will give you these values if you put them in. Okay. And we have one more to try, and then you'll have time to do some homework. Is everybody good with this one? Alright, we're going to do one more together. So let's rewrite it in its true standard form. That's going to be y equals a times cosine of b times theta minus 0 plus 0. So that's its complete standard form. This is A, B, H, and K. We know the amplitude is the absolute value of A which is going to come out to be what? Good. So that's actually going to be a positive 5 over 2 or a 2.5. Either one is fine. I just figured I'd show you as a decimal. And then the period is going to be 2 pi divided by what? Good. It comes out to be pi. So this graph's going to be more squished. Phase shift, we don't have one. Increment, pi over 4. My period divided by 4. Vertical shift, k, is 0. Midline is y equals k, which is 0. So is everybody good with all of those identifiers? The identifiers are pretty straightforward, right? So now we're going to take the function and get some values for it. So I'm going to take my original function, and I'm going to rewrite this as a decimal. Negative 2.5 is the same thing as 5 over 2 times cosine of 2 theta, right? But instead of theta, I'm going to plug in my first value, which is 0. So that's going to be cosine of 0 times 2.5. Cosine of 0 is 1. So that's going to be negative 2.5. So the graph's going to actually start down here at negative 2.5. Next thing I'm going to do is I'm going to plug in this value here, pi over 2. So I take my function and I replace theta with pi over 2. My 2's cancel, and that leaves me with cosine of pi. Can anybody tell me what cosine of pi is? I think it's 1, isn't it? Anyone know? I'll check. I just want to double check my work. Cosine of pi is negative 1. Yeah, negative 1. So this is going to be a negative 2.5 times negative 1, which comes out to be what? Good. So this here is at 2.5. Alright, so is everybody starting to see the pattern that this is going to take? So it's going to go down on this one, up on this one, down, up, oops, that's not on the line, down, up, and the 0 values occur on the ones that are in the middle. So all the zeros are right here, if you're wondering. And you could check that, like mathematically, if you don't believe me. And then we can just connect it. So do you see how you don't need to plug in every value of this graph? You can kind of start seeing what it's going to look like. Does everybody feel okay about that concept? You don't have to do every single one. That would take you a long time. So this is what it looks like in general. Okay. So I'll put in my dashed lines for my bound region. Can anybody tell me what this graph is bound between? Good. Negative 2.5 and positive 2.5, or negative 5 over 2, positive 5 over 2, and my domain hasn't changed. It's negative infinity to positive infinity.
Is it always gonna be 0?
Unless they put in a